Hello and welcome. I'm Carl Bradley with the University of Kentucky, and I'm joined with Darcy Telenko from Purdue University and Boris Camiletti from the University of Illinois. And we're going to talk about red crown rot of soybean today. So red crown rot of soybean is sort of a new disease to part of the U.S. It's been around in other parts of the U.S. for a while, and we'll get into that in a few minutes. But it's caused by a soil-borne fungus known as Calinecria illicicula. And if you look at some of the older literature, you may also see the name Cylindrocladium parasiticum that's listed for the same pathogen. So the name has changed.
As part of this disease, it actually has a wide host range. So we're kind of listing the number of genera that have been confirmed as hosts. What we've emphasized is peanut is one, and then alfalfa. So things that are of our legume family can be host to this new disease. And what we're showing here is Cylindrocladium black root rot, which is what occurs in peanuts here. So you can see kind of the symptomology it might cause if peanuts were being produced in the region.
So this is kind of the historical geographical footprint of red crown rot in the U.S. And this map kind of is current up through about 2014. So this map image came from a Farmer's Guide to Soybean Diseases, which is a publication from the American Phytopathological Society. And so there were several at the time. There were several soybean pathologists that helped kind of update this map, along with several other diseases. And so we actually did this at a meeting in 2014 where we were all there, and we literally took crayons to draw in where different diseases were on the map. And at this time, this is sort of what that distribution looked like in 2014.
This slide illustrates the progression of the disease here in Illinois since 2018 when it was first identified. And it's kind of show also the pattern of the disease spread here in our state. Unlike other diseases that expands maybe like in a continuous front, here we can see that it was more like an irregular pattern of at least how we could or how we were able to keep track of it. It was first reported in 2018, as I mentioned, in Pike County in West Illinois. By 2020, we had new counties where the disease was confirmed. It was more isolated locations. And by 2023, new counties were added. Like every year, we added new counties to this map, and this is how it looks now after processing of the samples from this year in 2024. So even when we use the same color for all the counties, I would like to mention that the disease is more prevalent in some counties than in others. We receive much more samples from specific counties and then we have other counties that we have only just one sample with the disease confirmed. So the prevalence of the disease is not the same in all the counties, even when we are using the same color, right?
And this is kind of what it looks like currently in Kentucky, as far as we know, at least. So in 2021, it was first found in Graves County, which is here, 2022, Callaway County, and then last year in 2024, Carlisle County. And so, at least in Kentucky, as far as we know right now, all of the counties are adjoining each other. They're all in the southwestern part of the state, but I think there's possibilities that it could be elsewhere in the state as well. And similar to what Boris just said about Illinois, although we have the entire counties highlighted here, there are just certain kind of small areas within each of those counties that are affected. So it's not across the entire county. It's still a little bit limited, as far as we know, at least in the counties in Kentucky that we know it's at.
And I guess for Indiana, our first reports came in 2022, where we had samples sent in from Decatur and Spencer. So actually, that was like the western part of the state, generally in the southern area of the state. After that, we've continued to get new counties, and you can see kind of our experiences that's distributed across the state in different areas. That being said, some of the counties, the Rush, Adams, Allen counties, we continue to have new reports of new fields. So back in 2022, there were in first in some of those fields, and then 2023 in the same counties, we found new fields. So again, this disease is moving across some of the farms, depending on their rotation and when we're finding it. So we can go back to some of those previous fields and find it again in the next season. It is sporadic though. So again, all we need is one sample in from each county to confirm that it's in that county. So that is something we do need to acknowledge. But I also think we're not, we'll get into a lot of this, but we're not ready, we're ramping up the search for this disease. So that's why some years we'll find more counties as we start looking for it. But I think it's probably more prevalent than we know in some of these areas. And so this is the kind of the final map for 2024. This map is now available in the Crop Protection Network. So it kind of shows you where the new distribution is occurring for red crown rot. You can also see that Missouri has now had its first case here in 2024. But this is a useful tool if you're trying to identify if it's maybe going to be in your area or something. You could use this map to kind of look at what counties is it been found in your area, and do you need to be watching for it for the next season.
And one thing I can mention here, Darcy, is that when you go to the Crop Protection Network and you pull up this map, you're going to see a map of the entire U.S. and you'll see some places down in like Louisiana and then kind of over on the East Coast. And so some of those are more historical. And we hope to kind of update this map as time goes by and maybe put some years on those observations where we could get a little bit more of a time lapse or kind of see when some of these areas first became affected. But when I talk to people down in the South, like in Louisiana, even though this disease was there a long time, it's not necessarily a problem now. And I think maybe you all have maybe had those conversations with some of them as well. But so just keep that in mind that this is sort of the new area here that where it's come since about 2018.
Correct. And as you move into this, that's where we bring up the disease triangle to kind of remind you the things that need to take place in order for really see an impact of this disease on your farm. So first of all, first you need the susceptible host. So for this disease, it would be soybeans, or if you have alfalfa in your rotation, or maybe we really don't have peanuts in Indiana, but if you had those crops, they could be the host. So we know the different species are susceptible to this disease. There may be some differences in variety and hybrids. I'm thinking partially right now, we haven't identified those for our area, but we'll be working on that. And then what growth stage the pathogen gets in. So we'll talk a little bit about the disease and how it gets in, and it probably gets in earlier on in the growing season versus later when the symptoms develop. The other side of it is understanding when the pathogen is present. So we do know this disease does overwinter in our soil. And so anything that may move soil could move this pathogen around. So we know it's now endemic in some of these areas. And so it'll be a problem down the future. But again, when we have the host present and the pathogen present, the environment still may need to be favorable for that disease to take hold. So if we don't have the favorable environment, if we don't have the right conditions for the pathogen to infect, then our risk where this triangle gets smaller decreases. But as we move into favorable conditions, maybe we planted at the right time where infection occurred and we had more disease develop in a season. Those are the conditions that may push the disease to appear and be more prevalent in some of these fields.
So in terms of the disease cycle, this pathogen is surviving in the soil. It's forming microsclerotia, like resistant structures that are present in the soil, and also in the plant tissue that we have remaining from the season. And this microsclerotia can survive several years. Based on the literature, it can be at least up to 7 years. We had some trials this year using inoculum or pods that were inoculated 4 years ago, and we got same disease level as we were using fresh inoculum. This microsclerotia during the season will germinate and the I5 will colonize the soybean roots. This infection can take place right after planting. In general, those infections occurring right after planting will result in more severe symptoms. These infections can occur more frequently when the soil temperatures are between 77 and 86 Fahrenheit. So this slide illustrates like the timing for the symptoms. We have like 3 groups of symptoms: the red discolorations on the lower part of the stem, the foliar symptoms and the perithecia. So this is the timeline for those symptoms during the season. We can find the reddish discoloration during the vegetative stages, starting in B1, B2. Then more close to the reproductive stages, we can see the foliar symptoms. We will see some very nice pictures in the next slides about these symptoms. And more towards the end of the season, we can find the white mycelia on the lower part of the stem, and under the right conditions, weather conditions, we can find the perithecia, that is these very characteristic structures for this disease. So this is how the stems look like. Here we can see the very nice reddish discoloration in the lower part of the stem. Here we can see like a more earlier stage for these discolorations. Here we have like two cropping systems with tilled and no-tilled system.
Yeah, and Boris, the picture on the right always reminds me that in Kentucky, we often see red crown rot a little bit more severe in soybean fields that are double crop fields, that they're planted after wheat harvest in late June, early July. And that may have to do something with the soil temperature that you talked about a little earlier. If you notice, that's a little bit warmer soil temperatures, but certainly we do seem to see a little bit more risk in double crop soybeans in our area at least. And and I don't know about the both of you, but it seems like when I've seen these symptoms in the vegetative stages, it seems like that you can find them, but I only found these because I knew red crown rot was already in that field. I didn't necessarily see any kind of foliar symptoms or anything that would draw me to those plants to look at these. How do you guys feel about that?
Well, I would say in Indiana, Carl, generally right now, I'm getting to the fields after we have foliar symptoms, so I haven't been able to catch these. Now we'll be going back into those years. So this year, now we have some fields I can go early. So I can't back you up on that one, but I'm sure that's what we'll see if I was there early enough.
Yes, here in Illinois it's the same. Every time that we visit a new field is because they saw the foliar symptoms, and we check when we don't see the perithecia, we can find very easily the reddish discoloration in the lower part of the stem. Yeah, in our trials we always checked, and yes, like right away after during the vegetative stages, we can find the reddish discoloration, will keep us more calm in terms
Yeah.
of having or not the disease.
Yeah, so that's a good point. So, really, even though you could see these symptoms as a farmer or a consultant earlier in the season, vegetative stage, it may be, as we get into some of those symptoms we'll talk about in a few minutes before it will really kind of draw you to that field to check it out. So, and that red discoloration that can kind of vary a little bit, and this just kind of shows it in the roots as well. But we can see anything from kind of a bright red in some cases to as that plant matures, it may be more of a kind of a darker reddish discoloration. And as that plant gets even older, you may actually need to take a pocket knife to kind of start scraping away the outer layers of that lower stem and root to be able to kind of start to identify some of that reddish discoloration in those roots.
Right. And so in addition to the red discoloration, we do, as the soybeans reach reproductive stages, we can begin to see some foliar symptoms. It has a generalized intraveinal chlorosis and necrosis of the leaves that can kind of look like other diseases, but we'll walk you through some of the symptoms that we've seen as they progress in the season. So here's some initial symptoms you can see. These plants we know are infected with red crown rot. You see that cupping and mottle that is occurring in some of those upper leaves, the beginning of the chlorosis that may mimic other diseases, but again, that chlorotic spotting of the leaves can occur. And then as the symptoms progress, you can then begin to see, the necrosis developing and leaving those leaf veins nice and green. And the one unique feature as these leaves begin to crinkle and brown up, that they remain attached to the plant. So that is one clue that may lead us more into red crown rot. But as we talk about some other potential diseases, maybe not. But again, something we've noticed is those leaves remain attached just compared to some other diseases.
Yeah, and so the other thing that's very diagnostic, but you don't always see, would be that the fungus produces these structures called perithecia. And so these are kind of orange, reddish orange, just colored spherical objects, and you can kind of see them there that will occur on the lower stem and root. And from like what Boris was talking about earlier, from a timing, from a looking at sort of the timeline, these are things that you would see later in the season, certainly after some of the foliar symptoms. So again, just some more pictures of kind of seeing a bunch of those perithecia on the lower stems and roots, and just a close up of what these really look like if you zoom in real close with your camera. And what's inside of these are spores called ascospores. And as far as we know, those ascospores don't really play a role in the disease cycle. But this is very diagnostic. If you see these, then it's highly likely that it's red crown rot. But there are some other saprophytic fungi that don't cause diseases that might just start to invade later in the season as plants just maybe naturally die, and they can sometimes produce some structures that might look a little similar. So again, if you see things like this, it's always a good idea to kind of confirm if it's red crown rot by sending it to a lab that where they can confirm it. And so again, here you can see some more perithecia on the lower stems here. But what I really want to point out in this picture is this pathogen is a really, really aggressive root rotter. And so even in maybe some of the previous pictures that we've shown, even if we didn't point out the root rot, you can definitely see it here. So definitely like, at the end of the season when plants were affected really severely, you can just pull up these plants or the stems that are left there, and there's really nothing left. And on the picture on the right, this is just using a knife to kind of cut in and looking at that sort of pith area. And you can see some discoloration here, kind of a dark grayish discoloration. But keep in mind that once plants get to this stage of maturity of being dead, they're just not going to look healthy in general. So I wouldn't necessarily use this as a diagnostic guide of telling you it's red crown rot, but that is one of the things that can occur. And so we know that this is a soil-borne pathogen. It's in the soil. Anytime we talk about soil-borne pathogens, that would include things like soybean cyst nematode or the sudden death syndrome pathogen. We know that they're generally going to be patchy, especially at the beginning, kind of when you first find the disease in the field. It's going to be very patchy. And so you can just see from this drone image, you can see spots out here in the field that are affected. And so some of these are small patches, some of them are pretty big. One of the things we noticed in this field that came from Kentucky is as you kind of look at this area here, that was just a pathway for water to drain into the ditch that's down here. And so you can see how that water movement and movement of the soil with that water probably moved that pathogen throughout the soil in that part of the field. And it's just more pictures. And I don't know, this is probably what you guys are seeing in Illinois and Indiana as well.
Yep, Carl, we see the same kind of patchy nature of this. We can actually see sometimes in some of our aerial pictures where we drag the soil across the field and we move it as well. So you can kind of see that sometimes as well. But again, yeah, in the fields I've been in, it's been very patchy, and some areas maybe up to 15% of the field. But again, in patchy areas, not the whole field being affected.
Yeah, here in Illinois, we have like all the scenarios. We have big patches, small patches, depending on the severity of the disease. Uh, and also depending a lot on the weather conditions. We have fields where the disease was in much bigger patches or areas in previous year than for instance in this year. So I think it's also related with the weather conditions can be very intense and then can go like lower in the following years too.
Yeah, and I think those, as you said, Boris, those patches seem to get bigger and bigger maybe over the years as well.
Yeah, so in this image, this is just one particular field. So here we have it's a commercial field, but showing a really high disease severity. But when I was talking with the manager, he said the previous season was even worse. So
Oh.
it depends a lot on the weather conditions, I think. And so we visited this plot at R3 stage, but based on how severe the symptoms were, we can say that the symptoms started much earlier. Here we saw like dead plants, plants with foliar symptoms, plants with no pods, plants with empty pods, also some healthy plants, fortunately. Yeah, but this is how a field with a really high disease severity looks like, and we can see like big patches instead of just small areas. So this is another field with a much lower severity. So here on the left image, we can see like the small areas with the disease. So we are using remote sensing, trying to keep track of the disease and to quantify the disease in every plot to have an idea also of the disease its intensity in the counties, in the areas. So we visited these plots and we created a model using ground truth data, and this model allows us to identify each pixel as this, or to classify the pixels as diseased or healthy. So we can see the distribution of the disease in the field, and for instance, in this particular field, we saw how the disease increased significantly from one year to the other, to the next one, where the disease area went from 6% to 26% in just from one soybean season to the other one. In the middle, they had corn, right? So we can see that disease can increase significantly from one season to the other one, and I think like an early detection will be crucial for this disease based on what we are seeing in the fields.
And Boris, my understanding is that you could almost kind of go back in time a little bit with some of this, right? Using satellite imagery, and maybe if you know
Yes.
these fields had it, you can kind of go back. And so I think that'll be really interesting to take a look at. I'm excited about your research, looking at that and giving us an idea of maybe, even though some of these detections didn't occur till, in the 2020s, maybe there might be some information there that we can draw from earlier maps that you may have been able to find it that way as well. So that's really interesting.
Yeah, the idea of knowing how the disease can progress over time is also useful to predict the disease. So if you have an early stage, okay, what can be happening the following seasons, and in order to take action to control this disease. So that's the idea.
So this is actually some of our work from Kentucky from 2021. Some of those initial fields that we found the disease in Graves County. Going back to those patches, it's really interesting. You can have really just dead plants almost next to very healthy looking plants. And so we wanted to try to get an estimate of what kind of loss that we're seeing from these patch of symptomatic plants versus these asymptomatic plants. And this just kind of gives you an idea. We hand harvested and kind of broke it out into these different categories. So you can see, here's plant weight, here's the number of pods, number of seeds, total seed weight. The blue bars are the ones that didn't have any symptoms, and the gray bars are the ones that had symptoms. And 50% or more reduction compared to asymptomatic and symptomatic. So that is troubling. This is sort of the worst case scenario, though. And again, in some of these fields, these patches might be pretty small, but kind of from what Boris was saying, in looking at the satellite imagery over time, they can certainly grow. And so it's not great news that this is this pathogen has the potential to cause these kind of losses, but it's this kind of information we need to know that's going to help us sort of look at research in the future as well.
And I guess as we move towards the future, the important thing is to understanding what's going on in your field, and do you have red crown rot, or is it something else? And so that's kind of this picture I'm showing here. If you're doing a drive-by of one of your fields, and you see this yellowing area, the question is, what could it be? And so let's talk about some of those diseases where they might mimic the same foliar symptoms, but what we need to look for to try to distinguish these possibly 4 different diseases that could have the similar foliar symptom. And so first is sudden death syndrome. And this is the kind of the message I've been telling a lot of my growers here in Indiana is generally, I think some of the areas we've just been like, okay, that's the patch. That's my sudden death syndrome patch. And we might have been missing red crown rot. But if we look at sudden death syndrome, it has this chocolate brown discoloration of the vascular system. So the vascular on the outer side of the lower stem there. And if you're lucky, you might even also then see the blue sporulation on the outside of the taproot there. And so those are 2 diagnostic symptoms we can try to identify if it's sudden death syndrome. Another disease we may run across is brown stem rot. So in order to find brown stem rot, you're going to have to cut that stem open. There won't be many lesions on the outside, but you can see just like its name, that center pith region is brown from that infection. Versus also in some areas we may have stem canker, and they have those lesions on the outside of the stem that are patchy, black, brown discoloration. So those are 3 other diseases that could mimic the foliar symptoms of red crown rot. We've already reviewed some of those the symptoms that we see in the lower stem for red crown rot, but that's just something I think you have to get out and look and really see what's going on in some of those poor growing areas of your fields.
So as far as management of red crown rot, we talked about how this disease, really, it's not new to the U.S. It's been around for a while, especially in the southern U.S. It's kind of new to our area. So I've got this kind of broken out into different things, looking at management then and now. And from what I mean by then is sort of the work that comes from that early work in the 1980s and 1990s. A lot of that work was done down at LSU. And you can find some of these recommendations in kind of what we call the Bible of soybean disease management, which is the compendium of soybean diseases. So that's where you can kind of go and kind of look at different management practices for different diseases. So we'll just kind of go through these one by one. And so I've kind of got the then and now places where we'll look at. So just starting off with resistant varieties, certainly that's one of the foundations of disease management. That's something we always want to look at whenever we're talking about disease management. And so I've got I've got an X, and for now I've got a big question mark. So certainly I don't think they had all the answers in Louisiana in 1980 and 1990 from varieties, but they were able to identify some varieties that were different, some that had a little bit more resistant and some that were more susceptible. I don't think anything was completely resistant, but were able to get some of that information. But currently, we just don't really know much about the current varieties that we're growing and how susceptible they may be. We may have some observations from some of our field trials or knowing what variety a farmer may have planted in a field that had red crown rot. But we don't know a whole lot, and we hope that some of that information will be coming soon. Certainly crop rotation, that's a great way to manage a lot of different soil-borne diseases and other diseases as well. But this one may hang around for a bit, and so it's probably not going to be a silver bullet. And Boris, you had some discussion about that earlier on some things that you're seeing as well in Illinois.
Yeah, we had some pods that were inoculated in 2020, and we got the same disease levels like if we were using fresh inoculum. So after 4 years, that inoculum was able to cause the same disease levels. And during these 4 years, the pods had only some weeds and snow. That was all. Yeah, the inoculum was able to cause disease in good disease levels too.
Yeah.
Yeah. So, I'm sorry. Go ahead, Darcy.
Yeah, I was gonna say in that rotation aspect, I think some of it is they looked at there was a longer rotation in the South that they could insert some different crops, right? And so when I look at Indiana, we still may be short on our standard corn soybean rotation, might still be a little too short to help that. But maybe if you can stick corn in for a couple of years, you might be able to knock it back down. Would be something I would recommend, I guess.
Yeah, we almost just need more crops, right, to kind of make it all work. But certainly, I think rotation with non-host crops still should be a part of the program, but it's probably not going to be a silver bullet here in managing this. But if we can kind of get to the point where we're integrating a lot of these different management practices, I think that's going to be part of it. Planting date, there was actually some work done down at in Louisiana looking at that. I think the key here, though, is really soil temperature, and so maybe not get stuck on the actual dates because something that's planted early in Louisiana might not be called early in central Illinois or northern Indiana or western Kentucky. Um, so paying attention to soil temperature is important. And so I think I have kind of I kind of cheated here. I have for now, I've got an X and a question mark. So I think certainly planting date or soil temperature at planting is still going to play a role here. But I think we still have a lot to learn. And a lot of this maybe goes back to um, are we dealing with isolates of this fungus that are maybe different than what was worked on in the 1980s and 1990s in the South? So there's still some questions there on how planting date may impact disease. And of course, managing other diseases and stresses, that's always important. Continue to do those kind of things. Darcy, what's your thoughts about those kind of that category there?
Well, I think it's just important to understand that yes, we're talking about red crown rot, but a field may have multiple diseases affecting that crop, and you could have a couple infections of different things going on. So soybean cyst nematode could be there. You could still have SDS out in the field. So we need to manage those as well to help minimize the impact.
Boris, have you
Yes.
seen any, yeah, have you seen any instances of where you had maybe multiple diseases in the field like this?
Yeah, we visited one particular field where we had red crown rot and white mold at the same time. And then our plant clinic has received samples where red crown rot was co-infecting plants with sudden death or other pathogens. So yeah, we don't
Yeah,
know the exact correlation between the
right.
diseases, but that is something that probably we need to explore.
Yeah, I think that just emphasizes that, continue to manage other diseases and problems that are out there. And maybe don't just focus on red crown rot. That might be just part of the problem, and you can have multiple things happening, unfortunately. Of course, we know that the way this pathogen moves is through any way that soil can move. And if you have red crown rot and you don't want to spread it to another field, you really need to clean off that equipment before you take it to another field. And I know it's almost impossible maybe to get every little um, speck of dirt off of a planter or off of some kind of tillage equipment, but I think doing your best in that's going to help slow the spread at least.
Yeah, probably if you know that you have if you have multiple locations and you know that one specific has the disease, probably keep that one to be planted last in the season.
Yeah, that's a good idea. And then seed treatments, right? So that's something that we didn't really have much of until a little bit more currently in soybean production. We see a lot of seed treatments now, but certainly we may have some options now with helping to manage red crown rot with some different fungicide seed treatments, and maybe even biologicals as we go into the future.
Yep. So as we move into 2025, what are our current best management recommendations? First and foremost, I'm just going to say we have to know if red crown rot is really the problem in the field. So if you don't know it's there, you're going to still probably have to wait for this season to see what happens. If you think you have it, please submit your samples to our diagnostic labs. We have active diagnostic labs in Indiana, Illinois, and Kentucky. They can really give you the confirmation that that's the problem going on in your field. So that's first and foremost. And then we'll go back through everything that Carl just reiterated. Rotation could be an option. There are some fungicide seed treatments with labels, so you could consider using them in those fields that we know we have a problem, manage the stresses and other diseases. And then if you're going to move to new fields that really haven't found the disease, maybe we try to make sure our equipment isn't moving the inoculum from field to field.
Yeah, and Darcy, I just want to go back to kind of what you talked about for submitting samples, because if you think back to that map that you showed, right? Why is that? How are those things related?
Well, generally, that's probably where we're going to learn whether the disease is in an area. Because in Indiana, it's the samples that were sent in by observant scouts or farmers that were seeing issues, and it wasn't what they were used to. And they're the ones that sent us the samples and said there's something going on. So that's the first point of where we learn if there's a new disease moving in the area, is sending it into our labs.
Yeah, and that so for us to turn a county, whatever color to show that it's present, those samples really need to be submitted through diagnostic labs. So that's really important. That really helps us as extension plant pathologists know where this disease is. It helps us get an idea of how quickly it's spreading. It's just going to help us overall do a better job of knowing where it's at and then managing it as well. And then I think the other thing that Darcy you pointed out here was the fungicide seed treatments, right? And so right now, as we record this, there's not a whole lot of treatments that are have red crown rot on the label. There's a few, but I think maybe we'll see some more in that area. So just not it's not just about using a fungicide seed treatment, but be sure that it's one that does have proven efficacy of red crown rot and that it's on the label. So that's also really important.
Yeah, so we have a lot of research going on. I think if we combine our programs, we must be testing every product in the market. And so we are testing seed treatments, including biologicals. We are trying in furrow treatments because that was a strategy that worked very well in peanuts like 20, 30 years ago. So we are exploring that method of application to other 2x2 treatments, for instance. Carl is leading the planted day trials. We plan to try commercial varieties. We have people at the USDA trying germplasm lines also to see if there is some variation and that we can include in our breeding programs. We are working on a rapid detection method to quantify the inoculum in the soil using molecular techniques, so we can have an idea or an idea of the amount of inoculum that we have in the soil and how it can be correlated with the disease intensity that we see during the season. We are working on remote sensing for disease quantification. We plan to explore the interaction of red crown rot with other diseases and also to explore the genetic diversity of the pathogen to see if we have exactly the same pathogen that researchers in the southern state had like years ago to see if it's exactly the same pathogen or probably adapted to this area.
Yeah, thank you, Boris. And I think I think we're all excited as we currently get some funding, but we've got a new project that will be starting up that's got some new funding that will be coming in, and it will really be helping us look at a lot of these things and working with Dr. Martin Chilvers at Michigan State University, especially on the development of rapid detection. So I'm excited about the prospect of the research we're going to do. I think we've got a good team here that a lot of us will be working together on this, and hopefully we'll be able to record some additional segments in the future on what we have found out from our research. So with that, thank you so much for tuning in, and if you have any questions or want to reach out to any of us for some additional information, we would be happy to receive your emails about that. So thank you very much.